Hello everybody, let's start our journey of learning mathematics from the ninth class and I've taken book of NCERT of ninth class and we will start with the number system. Let's see what are the content that we are going to study in this book. So first is number system, then polynomials, coordinate geometry, linear equations in two variables, introduction of Euclidean geometry, lines and angles, triangle, quadrilateral, areas of parallelogram and triangles, circle, construction zeros, formula, surface areas and volume, statistics and probability. So in total there are 15 chapters. Okay, so let's begin with the first chapter, which is a number system, right? So let's dive deep into it. So this is the topic that we are going to study under this chapter, that is the number system. So let me introduce you about the number system. So in earlier classes, what you have learned is that you represent a number line with like this, right? Like this only. So this is how you have learned up to now, that how you represent it. And on this number line, you represent numbers like 0, 1, 2, like -1, -2, right? So this is a way you have tried to visualize the number line. Okay, so now you can imagine like you are going from number 0, right? You are started from here, okay, and you are going in this direction. Okay, so you are moving towards positive direction, right? So this is the positive direction, this is the negative direction, right? So you will see numbers like when you go from 0, then you will find, yeah, you will come at 1, then you will come at 2, and so on, like that. And similarly, when you go back, you will see a number like -1, -2, up to so on, like this, right? And you call, so there in earlier classes you have learned that there were some name that are given to this representation, like if a number starts from 1, 2, 3, 4, up to so on. So if you are moving in that this direction, so if you are moving in positive direction, then you call this number as the natural numbers, right? You call them as natural numbers and you denote it by like this. So this is called as natural numbers, right? And when you include one more number, right? So let me just draw a number line here. So what is happening here? Number are starting from 1, 2, 3, 4, 5, and so on. So you call this system as the system of natural numbers. Okay. Now if I'm adding one more number in it, that is a 0. Okay, so the rest of the system will remain same, and I'm adding one more number into it, that is 0. So if I'm adding this number 0 into the system which were already there, that is in the natural number, then we call this system as system. We call the collection of all these numbers as whole numbers. We call them as whole numbers and we denoted it by W. Okay, in the books, which when you will go to high classes, you will see the notation. There will be some difference, like they use this notation sometimes. Sometimes they have some other notation to distinguish between the letter W and the letter that is used for the set of whole numbers, right? And this Z sometimes. So now let's move further from here. So earlier you moved to this direction, that is in a positive direction. Let's move behind. So you have taken one step back and you added a number 0. Now again go back. So you will see more numbers, right? Like earlier you were having, let me just draw it. Earlier you were, now you at this moment you will have 0, 1, 2, 3, 4, up to so on. Now go back. Now you will see a number -1, -2, -3, and up to so on. So now if a system include all these numbers like -infinity to +infinity and numbers like this, then you call this number as integers. Okay, so you are calling it as number integers, like integers. So notation is used as Z. Sometimes they written it like this. In some books you will see like this to distinguish number from the letter or alphabet Z. And this Z is nothing but it is a German word. Okay, it is German. It comes from a German word which is called as Zählen. Okay, and it means to count. So this is a German word. So German word Zählen. So notation is taken from that perspective. Okay. So these are the integers. Now can we move further from here? Yes. So a number, now you see you if a person is starting from this point 0, then it will jump to 1, then next step 2, then next C 3, and if it is going in the positive direction. Okay, if it is going in the positive direction, or you will get into the right. Okay, and if it is going back, then you it will see a number like -1, -2, -3, and so on. So is there any number between 0 and 1? So the answer is yes, there are numbers which are between 0 and 1. So what are those numbers? There are a lot of numbers. So one is called as rational number, right? And you denote it by Q. Or in some books you will see like this to distinguish it with the letter Q. Okay. So rational word comes from the word ratio. Like a ratio is nothing but like P by Q ratio, like okay, you write it ratio like you write it like this only, right? So how you call a number a rational number? Let's say a number R. So I'm considering some number R. We call it as is a number R is called a rational number. You call a number R as a rational number if when you call a number R as a rational number, if you can represent R as P by Q. If you are able to write R is equals to P by Q. And what is P and Q? P is again P belongs to you write belongs to write you write it like it belongs to integers, and Q again belongs to integers but except 0. It can't be 0 again. You know that 1 upon 0 is not defined, right? So that's why I'm removing that Q because you are taking as a general number. So this number must belong to some set, that from which set you are taking this number Q and P. So Q is here, so it should not be equal to 0. So that's why Q can be any integer but not 0. Okay. So this is one thing that you must keep in mind, that any rational number can be written in this form. Okay, is it clear to you? Now let us see. First, let us analyze our natural number system. So it started from 1, 2, 3, 4. So can we say, so my question is, can we say every natural number is rational? Can we say that? So let us see. So let's take a number 1. Okay, so 1 is a natural number. 1 is a natural number, right? So when you call a number as rational number, if 1 can be represented as P by Q. So if I am able to write P 1 is equal to P by Q, then we will say, and what is P and Q? P and Q belongs to integer and Q is not equal to 0, right? So if P and Q are equal, then P by Q is equals to P by P, which is equals to 1. That is, you can write 1 as P by P, right? So that means it is possible. So 1 can be written as 1 by 1. Again, 2 can be written as 2 by 1. 3 can be written as 3 by 1. 4 can be written as 4 by 1, right? So that means each natural number. So each natural number can be written as each natural number I call it as small n. Okay, n by 1, right? You can write it like this. So that means each natural number is a rational number, right? Is it true? Right. So is can we say the converse part is true? Can we say, can we say each rational number is natural? Can we say this? So the answer is, can you say, can you guess what is the answer? Answer is no, we can't. Because let's take a number 1 by 2. Okay, let's take a number 5. It is in the form of p by q, right? But this number will never come in the set of natural numbers. Why? Because natural numbers start from 1, 2, 3, 4, and this is nothing but 0.5. So that means it will come somewhere here. So it does not belongs to this set, but it is a rational number, right? So, but what we have done here, we just taken an element from the set of C. Let us suppose this is a set of, this is stack of rational numbers, and this is a stack of natural numbers. So what we have done earlier, we have taken one element from here, right? And we have shown that this element is also here in this set, right? You can take any natural number, and you can show that it is here as well. So that means this whole set this whole set is in this set only, right? So that is, it is contained in this, right? Or you can say it is smaller one, right? Now now if I take a rational number, here I take a rational number 1 by 2. It is rational number, it will be in this set, right? So it is a stack of rational numbers, and it is natural set of natural numbers, right? Now I have taken one element 1 by 2 which belongs to this set because it's a rational number. It is written as p by q form, right? P by q form, and 1 by 2, one is one is integer, 2 is integer, so it is in the rational form. It is a rational number, right? But 1 by 2 will never be in this set, and in the set of natural numbers. Okay, so this will never be possible, right? Because the natural number starts from 1, and 1 by 2 is way beyond 1. Okay, so that means there will be some numbers in the set of rational numbers which are not natural numbers, right? So that means natural numbers are contained in rational number. This is the sign of containment. That is, all the natural numbers will be in the set of rational numbers, but Q, that is the set of rational number, is not contained in natural number set, right? So that means there is some number in the natural number which in the set of rational number which are not in the natural number, or there is at least one element. If we are able to show ki- that there is at least one element which belongs to the set of natural rational number, which we have taken as 1 by 2, this element belongs to this set of rational number, but this 1 by 2 is does not belongs to the set of natural numbers. So that means this has some extra element. Okay, so that means this can't be in the set of natural numbers. So this result you should keep in mind. Now similarly you can do for a set of integers. Okay, set of integers starts from 0, then 1, only one extra element. Okay, 4. So again you can write all these elements as 0 by 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1, right? So this is again in p by q form. P is integer, Q is integer. Again, this is in P by Q form. This is again in P by Q form. This is again in P by Q form. This is again in P by Q form. Q can't be 0, P can be 0, right? Because we have taken as P, Q belongs to set of integers and Q is not 0. So Q is not 0 in any of these numbers, and so on. You can go like this. So that means each whole number is rational number as well, right? Isn't it? Because you can write, you can take a stack of, I have taken a stack of integers and again a stack of rational numbers. So you take any element from this set, okay, and you have shown that this element is also here. Okay, take any element in Z, you have proved above that it is here. So that means this whole stack is where is in the this set. This whole stack belongs to which? This whole stack is in this set. But again you can take this 1 by 2, which is a rational number, but 1 by 2 does not belongs to this, because in integers what you do, you start from 0, the next number comes is 1, but 1 by 2 belongs somewhere here, right? But in whole number you started from 0, then the next number that comes is 1, then after 1 you will get a number 2, then number 3, then number 4. There are no numbers between any two consecutive numbers, but 1 by 2 belongs between 0 and 1. So it is a rational number, yes. Why? Because 1 by 2 is a rational number, yes, because it written in the form of P by Q. And if you are able to write any number in this form, you call that number as rational. Okay, so you named it as rational. If you are able to write any number in the form of P by Q, you will say it is a rational number. But this number does not belongs to the set of integers, because after 0 the number you will get is 1, and 1 by 2 lies between 0 and 1. So that means again this set of rational number is bigger than the set of integers, or you will say this set is not contained in, or you can say Z is contained in rational numbers, but rational numbers, the set of rational number is not contained in Z, or the set of integers. So this is again a next result, right? Now similarly you can move, sorry, this is not set, but this is whole number set, right? So this is whole number set. So this is a set of whole numbers. Okay, so it is not, because yeah, so it is set of whole numbers, because whole number system starts from 0, right? So it starts from 0. Again you can go back, you can go next to the set of integers, right? So in integers what you have observed, that you start with 0, you can go in this right direction, okay, you can go in left direction, numbers are everywhere like this, okay, but there are jumps. From 0 you will go to -1, from the 0 you can go to 1, then 2, then 3, and so on. Again, in the same scenario, you can write each number as -2 by 1, -1 by 1, 1, 1, 1, 1. So that means you can write each integer as p by q, right? By putting q equal to 1, right? You can do that. So that means each integer is contained in, or you can say each integer is a rational number. So that means the complete set of integers is contained in the set of rational numbers. But again, you can take that example of 1 by 2. 1 by 2 belongs to the set of rational numbers, but 1 by 2 does not belongs to set of integers, because why? Because after 0 you will either get 1 or -1, but 1 by 2 lies somewhere here, okay, which does not belong to set of integers. That means Q does not contain in Z. So this is the next result, that this thing you should keep in mind. Now, other thing that you must keep in mind is that the representation of the rational number is unique or not. What do you mean by unique? Suppose I'm writing 1 by 2. So is this the only way to write, or is there any way, or any, you can say, a similar way to write 1 by 2? So can I write 1 by 2 as 4 by 8? Can I write it like 8 by 16? Can I write it like 12 by 24? Yes, because after cutting this, you will get again 1 by 2. So representation of rational numbers is not unique. This thing you must keep in mind, right? Because there are a lot of ways to write a number, right? So it is not unique. You will not say that there is only one way to write 1 by 2. There are a lot of ways, there are infinite number of ways to write 1 by 2, right? So so this thing you must keep in mind, right? So they are all equivalent, they are all equal, right? You know that, right? So there are a lot of ways to write it. So this thing you must keep in mind. Next, sometimes they ask a question like um, how many numbers, like lies between 0 and 1? How many rational numbers you can find between 0 and 1? So can you tell me what is the number that can come between 0 and 1? So easiest is the middle one, 0 plus 1 by 2, that is 1 by 2, the half of it. This is the rational number because it is written in the form of P by Q, right? Can you guess another number? Again, another very easy way, right? What is it? Now consider this and this number. Now take 1 by 2 plus 1 and now divide by 2. So that is 1 plus 3 by 2 into 2, that is 4 by, sorry, 2. So that is 3 by 4. Again this lies somewhere here. Right, middle of it, again you can take the middle of it. So again you will have 1 by 4. Again, now you can take this number and this number. Okay, take this number and this, take their middle. So how many numbers you can uh, find between these any two rational numbers? Infinite, right? So there always exist infinite numbers between any two rational numbers, right? Is it true, right? Because just keep on doing this. Just take two rational numbers. Suppose I'm taking 1 by 2 and 1. So these two are rational numbers, right? Just take the middle of it. So this is the middle of 1 and 1 by 2 again, right? So it will be 1 by 2 plus 1 by 2, that is 3 by 4. So it is 3 by 4. Right, now take the middle of this number. So now take the middle of this number and this, that is 1 by 2 plus 3 by 4 by 2. So this is again the middle. Okay, so like this you go on doing this. So you can insert infinite numbers between any infinite rational numbers between two rational numbers, right? Isn't it so? But same, you will keep in mind there is no numbers between. Suppose I'm taking whole number set of whole. So there is no number between 0 and 1. After 0, you will get number 1. After 1, you will get number 2. After 1, 2 you will get number 3. So in whole numbers, there is no number between any two consecutive numbers. Okay, you can take 2 and 3, there is no number between these two. in whole number system or in natural number system or in integer, right? But this is the first distinction. But in rational numbers, okay, in 0 and 1, you can have infinite rational numbers. Infinite rational numbers, right? You can identify infinite rational numbers between these two rational numbers, right? So this is one difference between how the rational number set, the set of rational number, or yeah, the set of rational number and the set of natural numbers, integers and whole number differs with rational number, right? So this thing you must keep in mind. So one other type of question that can be asked. Uh, so this we have proven that there are infinite numbers between any two rational numbers, but it is asked to find. Sometimes it is asked to find five rational numbers between 1 and 2. So to identify five rational numbers between 1 and 2, how you will do it? Okay, so there are ways to do it. Okay, so let's see the approaches that we have. Let's see how we are going to identify these numbers, right? So let's take first approach. So what you will do? So so you have to find the rational number. Suppose between R and S. Here R is 1 and S is 2. Okay, so what you will do? That the thing that we have done, just take R, take S and divide by 2. Just take the middle, right? In this way you can find out, right? The one that we have that I've just shown you above, like here it is asked between 1 and 2, right? So just take these two numbers, add them and divide by 2. Just take the half of them. So this will be the next number, that is 3 by 2. So this is 3 by 2. You are here, you have to insert five numbers again. Next you will take uh, 3 by 2 and 1. Okay, now take the middle of it. So that is 1 plus 3 by 2 by 2. So that is 5 by 4. Again, this is 5 by 4. So two numbers you will get between 1 and 2, you have to insert five numbers. Now you can do in either way. You can take half of it, and half of it you can do like this. Like you can next you will choose 3 by 2 and 2, just adding these two numbers and doing their half. So 7 by 4. So this will be 7 by 4. Okay, again, so okay, sorry. So you have inserted how many numbers between these two? So you have three numbers. Again, you can take half of these two, or half of 3 by 2 7 by 4, or half of 5 by 4 3 by 2, or 1 and 5 by 4. I can take this number, so this number will be 1 plus 5 by 4 by 2. So this number will comes out to be 9 by 8. Okay, so 1 2 3 4. So till now we have so we have inserted four numbers. The next number will be, you can take anything, so you can take these two, 5 by 4 plus 3 by 2 by 2. So you will get what number you will get? You will have 8. Okay, so and next you will have here 11. Okay, so 11 by 8, you will get the next number. So in this way you have inserted 1 2 3 4 and 5 number between 1 and 2. So this is one of the way to insert five numbers that I have also discussed above, right? So what next you can do? So what would be the next second approach, how you will insert the five numbers? It is quite easy. So what you can do is that um, so let's start with uh, this thing. So you are asked to insert five numbers like 1 and 2. Between 1 and 2 you are supposed to add five numbers, right? So what you will do, you will just um, So it is asked you that five numbers. So just add 5 plus 1, that is 6. Okay, so this just add it. Now what you will do, just 1, then divide this by 1 by 1 and 1 by 6. Then next will be, sorry, next will be, so first number is 1. Okay, so let me just elaborate this to you a bit more. So 1 can be written as 6 by 6, right? And 2 can be written as 12 by 6. You can, is it okay? So because I have told you earlier that there are a lot of ways, or infinite ways to write a rational number. So 1 can be written as 6 by 6 and 2 can be written as 12 by 6. So next number will be, you can say 7 by 6, then 8 by 6, 9 by 6, 10 by 6, 11 by 6. So 1, 2, 3, 4, and 5. So this is another way to insert five numbers. So again, let me just recreate this question and ask you to find a number like seven numbers. Like seven, insert seven numbers, or find seven numbers, seven rational numbers between one and two. So we all know the answer will not be a unique, right? It may vary because there are infinite rational numbers between one and two. Okay, so this is one of the way to show. You can do whichever method you feel good with, or you can feel easy to go with. But the method that we have discussed is either by taking the half of one and 1 by 2, then go on doing half of, take any two consecutive numbers, take their half, and go on inserting the numbers. You can insert infinite numbers between any two rational numbers. So these are not only the way. Other way is to just take, if it is asked that you have to insert seven numbers, just add one in it and it make it 8. Now write one as 8 by 8, okay, and 2 as 16 by 8. Okay, so I'm just rewriting these numbers. So it will be 2, it is 1, right? So again it is 1 because we have to insert numbers between 1 and 2. So next number will be 9 by 8, 10 by 8, 11 by 8, 12 by 8, 13 by 8, 14 by 8, 15 by 8. So again, 1, 2, 3, 4, 5, 6, and 7 numbers. So you have an inserted 7 numbers between 1 and 2. So this is the way to uh, add these numbers, or add the numbers that are required to be added between any two rational numbers. Okay, so just keep this thing in mind, right? So it can be asked like five numbers, 10 numbers, or whatever, like a number of numbers between any two consecutive numbers or any two rational numbers. So you can add accordingly, right? So this thing you must keep in mind. So again, there are questions like zero can be a rational number. Is zero a rational number? Yes, because zero can be written as 0 by 1 and it is p by q. So yes, it is a rational number. Okay, so you can, next question can be asked like add six rational number between 3 and 4. So this is the question of exercise 1 by 1. Okay, so add six rational numbers between 3 and 4. So what you can do, first way is to start doing half of these two numbers, right? Like 3 plus half of 1 by 2. So this number will be 7 by 2. Then take the half of 3 and 7 by 2. So this number will be 3 plus 7 by 2. And just take the half of this 7 by 2 plus 4 by 2. So this is half of this number. So again, now we have inserted one, 2, 3 numbers. Now again, you can choose any two numbers and just again adding them and dividing by 2. Okay, so this, in this way you can keep on doing like this, and you will have as many as numbers you can insert between any two rational numbers. Another way I have shown you, like it is here, it is asked like six rational numbers, just add 6 plus 1, 7, and now write 3 and 4 in such a way that after dividing you will get 3 and then you will have 4 like in the way we have done above, right? Like 3 can be written as how you can write 3. So here 7, so you can write 21, right? Because when you divide it by 21, 7, okay, so 7 3s are 21, okay, and then here it is 7 4s are 28. So next number will be 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, and 27 by 7. Again 1, 2, 3, 4, 5, 6. So again 6 number you have inserted between these two numbers. It's just that you have to rewrite this properly, right? And the key to remember is that suppose you have asked 8 number to insert 8 rational numbers to insert between, suppose it is asked between 2, or you can say 5 and 6. Okay, so what you will do, just add 1 in 8, so it is 9. Now take denominator as 9 in both the side. Okay, so again here it is 5, here it is 6. So what number should I put here so that after dividing by 9 I'll get 5? So it will be 5, right? And the next number will be 54. Now divide this by 25, 9 by 45, you will get 5. Okay, and then and here when you divide 54 by 9 you will get 6. Okay, and then the next number will be 46 by 9. Now keep on adding one number above. So 47, 48 by 9, 49 by 9, and so on. You will insert 8 numbers. Okay, so these are the ways to handle such kind of questions. So, and another type of question that can be asked, like the whether the statements are true or false. Okay, that every natural number is a whole number. Yes, every natural number is a whole number, right? Because natural numbers start from 1, 2, 3, and whole number starts from 0, 0, 1, 2, 3. So this thing is already there. Okay, so this is a set of natural number, but in the whole number we add one more number which is 0. So every natural number is a whole number. Every integer is a whole number, not true. Why? Because integer starts from, like, if there are negative numbers. Okay, so these are the numbers which are there already in integers, but whole number starts from here. So every whole number is a integer, yes, because but every integer is not a whole number, because there are integers, that is minus 1 is the integer, but it is not a whole number. Okay, so this statement is not true. Okay, right? And every rational number is a whole number? No, it is not true. Okay, we have seen earlier that 1 by 2 is a rational number, but it is not a whole number. Okay, so this is about the number line. Okay, so how we visualize the number line, natural numbers, how they look like, natural numbers, whole numbers, integers, okay, and then rational numbers. Okay, so and how they are related to each other, how many numbers are between any two natural numbers, or whole number, or integer, or rational numbers, right? How they differ from each other. So from the above observation, we can say the set of natural number is contained in the set of whole numbers, and the set of whole number is contained in set of integers, and the set of integers is contained in set of rational numbers. So up to now, we can say the set of rational number is bigger one. All the sets are contained in this the set that is set of natural number, set of rational number. Okay. So this is all for now. So next we will start with the set of irrational numbers. Okay. So up to this, you practice some questions. Let me know if you have any doubt or you want me to explain any other thing in the one which I have explained above. So thank you very much. See you in the next video.